All right, guys. We're going to do, this is going to be a video answer key for the practice 4.1 that we started on Friday. So we've got some questions about how to do calculations on free falling objects here. And what I want to do real quick is I just want to go back to, um, I've got the notes that we did on Friday saved. So you'll notice that if you have your Cornell notes, this is the same thing that you took your Cornell notes over. So what I want to do here is I'm going to cut out um, our equations here, and I just want to put them at the top of my page. And let's make that a little bit smaller. Okay, so that was one of our equations there. VF equals VI minus 9.8 times delta T. And then we also had a second equation, so I just want to have these at the top. That way I can reference them. So I'm going back to my notes just like you guys can go back to your notes. By the way, sorry if you hear my daughter in the background. She's playing with Mrs. McSparron right now, so she might be talking about puppy dogs. She's been talking about puppy dogs a lot lately. Um, there you go. I don't know if you can hear it, but she's screaming puppy dogs. Um, okay, so, they're watching America's Funniest Home Videos, and there's puppy dogs on America's Funniest Home Videos. That's what's going on. Okay, so there's my two equations. Let's separate them a little bit. So I've got VF equals VI minus 9.8 delta T. And then I've got YI equals 4.9 times delta T squared minus VI times delta T. Okay, so you've got those, I've got those. And so let's do another little thing real quick here. So let's just remember that YI just means height, okay? Height and YI are exactly the same when we use these equations. All right, so number one, Mr. McSparron drops a bowling ball off the roof of the school, and it takes 2.5 seconds for the bowling ball to hit the ground. Calculate the height. Now look, it tells me I need to find the height. So instantly, right there, I know that I need to use this second equation. So I'm going to go ahead and I'm going to snag that second equation. And I'm going to put it in here. That's going to be the one we use, okay? So that's our equation. So calculate the height. Now, what else do we need? So we know we're looking for yi. So I need to know delta t, and I need to know vi. So delta t is the time that went by, and they told me that 2.5 seconds is the time that went by. So delta t is 2.5. VI, okay, remember this is me standing on the roof and dropping it. So right the moment I let go of it at the very beginning, it has no velocity. So VI is going to be 0. So all I'm going to do now is I'm going to plug these things in. So 2.5 will go there, and it'll also go there. So I'm going to end up with yi equals 4.9 times 2.5 squared minus 0 times 2.5. Okay, now right away, I want to look at this part. Now, I know that 0 times 2.5 is just 0. So anytime adding or subtracting 0 from something doesn't really do anything. So that 0 means I can cancel this thing out right now, okay? Because it makes the whole thing 0. So now all I'm looking at, and I'm just going to erase that to make it cleaner. Okay, I'm looking at 4.9 times 2.5 squared. So now we're just doing math, okay? So 2.5 squared, when we go over to the calculator, is just 2.5 times 2.5, 6.25. Okay, so that makes 6.25 times 4.9. And let's go and do that now. So we're going to multiply 6.25 times. Notice I just left it on the calculator. I mean, I don't need to type it again because it's already there. All right, so I've got 30.625. Let's go there. yi equals 30.625, and that's a height, so it's got to be meters. All right, good. So there's the answer to number one. Now, number two, for the same bowling ball, how fast will it be going right before it hits the ground? Okay, so now what we're looking for is how fast. Well, how fast sounds like a velocity. So let's use, and specifically, it says how fast, let's look at this. It says how fast will it be going right before it hits the ground. So that tells me at the end, that's where I'm looking for its speed. So that sounds like it's VF, not VI that I'm looking for. So let's copy that equation right there. Okay, so now I'm looking for VF. Okay, so like VF is my question mark. So I need to know VI, and I need to know delta T. Okay, so VI, well, again, we know that's 0. We found that right there. Okay, so we know VI is 0, and delta T, again, just like up here, TI, or delta T is 2.5. So let's put in 2.5. So now all I'm going to do is I'm just going to take VI, plug it in, 2.5, plug it in, and I'm going to end up with VF equals 0, not VI, but 0, minus 9.8 times, and we said we're plugging in 2.5. Okay, so now I'm just doing the calculator again. Negative 9.8 times 2.5. Okay, so clear. All right, 9.8. Well, hang on, we got to go negative 9.8, and let's see. There's my negative. Okay, times 2.5 equals negative 24.5. Nice. Negative 24.5. And that is a velocity, which means it needs to be meters per second. Nice. There's our answer. Okay. Let's go on. A tennis ball falls off the edge of the table. How long will it take the ball to reach the ground? Okay, the table is 1.5 meters high. Okay, so right now, okay, I see that 1.5 meters high, and I know that height is yi, so yi is 1.5 meters. Okay, well, there's another big clue, okay, guys? So if they're giving me height, that means I probably need to use this thing. So let's copy that. And let's put it right there. Let's give myself some space because it's going to be a longer calculation. Okay, so again, I know my other variables are delta T and VI. VI, again, we know that's 0. Now, delta T becomes my question mark here. So I'm trying to solve for delta T. So I'm going to take my 1.5 and I'm going to plug that in for yi. I'm going to leave my delta T's, and then my 0 is going to go in place of VI. Okay, so let's see, that's 1.5. All right, so yi now is 1.5 equals 4.9 times delta T squared minus 0 times delta T. Well, now this would be a tough calculation, except for the fact that that 0 is right there. Okay, so because the 0 is there, remember that makes that whole thing 0, which means I can cancel the whole thing out because it makes the whole section 0. So I'm just going to go ahead and erase that. All right, so now I'm left with this bad boy right here. And this is not as hard as it looks, okay, guys? So you guys are solving some similar stuff in algebra right now. Just pretend like that delta T is an X, and suddenly this looks a lot easier. So I'm trying to get delta T by itself. So the first thing I need to do is to get rid of that 4.9. Get rid of, I'll do that. Get rid of this 4.9 right there. Well, how do I do that? 4.9 is multiplied by delta T squared, so I need to do the opposite of multiplication, which is division. I'm going to divide both sides by 4.9. And then we'll do 1.5 divided by 4.9. Okay, 1.5 divided by 4.9. And that's 0.31, we'll call it. Okay, so I've got 0.31 equals delta T squared. Okay, so now I still need to get delta T by itself, but I've got this squared there. So how do I undo a squared? Well, the opposite of squared is square root. So I take the square root of both sides, and that cancels out the squared, so that means that delta t equals the square root of 0.31. Now watch what I do here, okay? Oh, shoot. Do I not have a square root? I don't know how to get square root on there. Okay, so you guys aren't going to be able to see this, but I'm just going to do square root on my calculator on my phone here. Oh, my phone has low battery. Sorry, this is boring for you guys. But let's see, that was 1.5 divided by 4.9. And then I want to square root it. All right, so what we're looking at here is 0.55. And delta t is a time, okay? So that means it's 0.55 seconds. That's not 0.555, that's 0.55 seconds, all right? And so that's the time that it would take. There we go. All right, now, the last thing I want to do here, number 4, how fast will a tennis ball be going right before it hits the ground? So this one looks just like number 2, okay? Very exact same question. So I'm going to use the exact same method. I'm going to copy this equation. Remember, that equation will give me final velocity. All right. So VF is my question mark. VI is 0. And delta T, now we know that it is that 0.55. Okay, 0.55. So I'm going to take my 0, I'm going to plug it in there, I'm going to take my 0.55, I'm going to plug it in there, and I'm going to end up with VF equals VI minus 9.8 times 0.55, and I messed up. I left a VI in there. I should have put a 0. There we go. Okay, so now we just go to the calculator. So negative 9.8 times 0.55. Okay, so let's go negative 9.8 times 0.55 equals negative 5.39. All right, so negative 5.39, and that's a velocity, so that means it's meters per second. Okay, there's the answers.